Hi, I'm Camilla. Today we'll go through a demo showing the fast prototyping capabilities of MLReef with a multi-class image classification task on bacteria itself. We also will show you the general concepts of MLReef and how it works with a hands-on tutorial. So let's jump to it. MLReef is an open source and Git-based MLOps platform. Simply said, it's a community workbench for creating AI. We provide the end-to-end development environment, while all the users, so you provide the content and scripts and data that you require to creating machine learning, and all this within a highly collaborative and reproducible environment. On a little bit more technical side, our objective is to use existing best practices known from software engineering and encompassed in the terms DevOps, and also known from platforms like GitHub or GitLab. And we add machine learning specific tasks on top of that. So this is pipeline management, modular containerization of scripts so that everyone can use them and reuse them at any given time, model tracking and management, and a little bit later on also the deployment stage. So what we try to achieve with this is to go a little bit away from the unstructured and notebook-centered ML development towards a more modular and more orchestrated and transparent and collaborative MLOps that is at the same time easy, but also very flexible to use. So MLReef is a unified solution for the entire machine learning lifecycle, built from ground up as a single application. What you can see down here below are the different phases of the machine learning lifecycle with distinct features and functions that we already cover with the circles in them, with the maturity stage that these functions are in. So at the end, this means MLReef will provide you a way to really super fast prototype. And as you know, this is a very crucial part in machine learning development, a completely new level of collaboration. You will see that later on, an effortless means of sharing your work, very granular reproducibility on every step, and complete ownership and security. MLReef is open source. It works on premise and it even works completely offline. And if you log on now to MLReef.com, you even can use free computing resources. So let's jump now into our demo. As I said before, we will do a bacteria classification task. Within this demo, you will discover how to manage repositories very easily, the source code management part of it, and the crucial aspect, which is the publishing process, and understanding the CI/CD mechanisms that underlie MLReef. We'll do some data preprocessing shortly. I will show you how the concurrency in the experiments in the pipelines will work, and we will see some experiments that we will create. So yeah, without further ado, let's jump to it. So when you arrive to MLReef, the first thing that you will encounter is the dashboard. The dashboard itself hosts all the projects that you own, or if you want to explore public projects made by the community, you can do it here. The special thing about MLReef is that we structure the machine learning lifecycle in modules. These modules can be seen here. Machine learning projects is where you host your entire work, you create pipelines and start your experiments. These here are what we call code repositories. They are Git repositories where you store and manage your scripts that are specific for a function within the machine learning lifecycle. In this case, models, data operations for data preprocessing, or data visualizations. Let's jump now into one and explore what we can do. For example, this bacteria classifier here, as we want to create a bacteria classifying task, right? As you can see, these are Git repositories. You have all the functionality in them as you're used to. So you can create branches, merge them together, and using Git to push your local changes to this remote directory. This is now a repository from Erika, and she has created a bacteria classifier, which is a Python script based on Torch and taking the architecture from MobileNet. The only part that is MLReef specific in this case is the annotation segment. So with MLReef, you don't need any library. We really do not want to be intrusive. The only thing that you need to set here is several parameters that you want MLReef to store and that you want to be able to address them later on in the pipelines very easily. Furthermore, you will see also a requirements txt file. In here, you can describe what dependencies your script has. The simplest way for you to start is by forking this project. This will move the entire project to your own namespace, where you then can change and adapt the script to your needs. In our case, I will move to my already forked script. This is now my own script. And as you can see, it has the same structure as Erica's. But I have here the publishing button, which enables me to publish my code repository in this case. It is a simple wizard that you can follow, where you can select different branches that you want to publish, which will be versioned in the background and make your script immutable and always workable for the rest of the community, or your team or yourself can decide. The simpler thing is you select the entry point, select the base environment, and just basically click through. This will start a CI/CD based pipelining mechanism that will override the previous version if you want to, or if it also can store parallel versions with prior ones. So you can see also now that the job is running, can review the job log and see what's going on and see if really that's succeeded or not. But now let's jump to our machine learning project and see how we can use this newly published script. I will search my project and type for bacteria. This now is a machine learning project itself. In here, we now store our data using Git or Git LFS. It contains, in this case, some sample images to review that these are really bacteria images. In the data folder itself, you have already a split taking place with a train directory containing 9 subclasses of bacteria. The special thing in this data tab is that you have data ops and data visualizations. These are specific pipelines for running data preprocessing or data visualization tasks. Let's jump to data preprocessing. This is a data preprocessing pipeline view. In the middle, you can create the pipeline based on the previously published scripts of the team or of the community itself, which can be found here on the right side. The first thing that we need to do is we select the data that we want to preprocess. You can select the master branch itself. If you have created different branches, you can switch to them. But for now, let's stick to the data folder that we just want to preprocess and create a pipeline. As a first step, let's simply add noise to our images. The cool thing about MLReef is that every script that is published before is made a simply drag and drop element that you can then address the parameters here, review the code, or also jump to the repository itself. And if you like what you see, fork it, adapt it to your needs, and so on. This means that you do not need to start from scratch, but you can use the power of the community to really enhance your work and get going. In this case, our first operation will add noise to the images. I will store the output of this operation in the out1 folder, and the model will add a salt noise speckles to the images. I can also concatenate by dragging another operation directly underneath it. This second operation in this case would also take the input data from the data directory that we selected above. But if I want to truly concatenate it, I would state that the input data is the output data of my first operation that I used. And the images created with the color modifier should be stored in the final directory. Include the brightness, the contrast, and leave saturation at 1. Now it's just simply execute. Select the machine and execute my pipeline. This now will create a new data set. And this new data set is also stored within a branch in your data repository. I always can go back here to change and to create a new data set and iterate fast on creating different versions of data set and trying to find out which of the data sets that I created work best with a model and not only the other way around. I can proceed through the results and seeing that my pipeline has just started, review what is going on. With Git, I can always see what version of data I have used by clicking on it, and you will see that this stores the Git commit hash to the pipeline itself. I also can see what data operations I used, and I can rerun my pipeline at any point of time. This now is running, but I can explore other data sets that I created before. For example, Smart Tuner. If I click on it, I can see that there were some similar folders created before. There's a final folder which I can discover, train. And in here, you will see that my original images that I had in my data set have now changed. I can see that my initial data now has a noise and cropped data operations on top of that. So let's just immediately jump to experiments. So now that we are here in the experiments tab, let's simply create a new experiment. This experiment pipeline looks very similar to the previous one, except that in this case, obviously, I will be able to search and use models that the community and the team has created. We'll also start by selecting my data. And in here, I will type material classifier. This one is mine. I will just simply drag and drop it and be able to address the parameters quite easily. As you can see here also, I have a drop-down showing what kind of versions of this model I can use. And it will also include now the version 2 of the pipeline that I created just moments ago. But I could also switch to a previously one and use the before state of that. In this case, I will just fill it out. I'll put the number of classes is 9. I will use a pre-trained state of the model and train for 15 epochs. In here, there's really completely flexibility on one side because I have access to the source code, I can change it and so on. And on the other hand, I have this very easy and intuitive way of using models, addressing them very flexibly as well through the parameters and just executing them. What I also could do is just iterate faster by dragging another model into the pipeline. And this would train then separately in 2 experiments at the time. And I can use this on many, many other fields and options. I will leave this up for now and just start my training. If I want to make adaptations and to iterate fast on that side as well, I could return to the pipeline, expand this view, and change, for example, the number of epochs to 20 and execute the same pipeline straight again. So now this is the experiments overview. In here, I have a list of all the experiments that I have done before. I can rearrange to the created states and I can see that 2 of my experiments are now running. These are I've created just now. I can customize these columns by adding, for example, the number of epochs that I'm running, the value, the validation accuracy that my models are generated, and rearrange also to display the ones that have been working the best. I always can go into more details by expanding any of these experiments. See one that has some metrics in it, and review the performance metrics that this experiment has achieved. You can see what version of data I have used, what branch I have used, what model and model version I've used to run this experiment, and seeing also the source code behind it. And I can see all the parameters that were relevant for my model. I can also go more into details by clicking the experiment name, reviewing all the parameters that were relevant. I can view the pipeline again to the states where I executed it. I can see the training log, so everything that really happened in the background. And I can access the artifacts or the output files that were generated during the model training. In what time. And on top of here, I can review all the experiments at the time and picking one that worked the best for me. I can add different panels and switch to any parameter that are relevant for my case. MLReef can help you operationalize and make your machine learning more collaborative, structured, and reproducible. Reach out or simply start following this or upcoming tutorials. And thank you for watching.